Hey everybody, thank you for joining us again on these videos. We're talking about the separation of our campus core and our data center core, kind of the reason why we're looking at it, and then the deep dives into each one of these categories. And so for this one, we're going to focus more on what it means to design a data center. If you haven't already split that off, what are things we want to achieve? Like what goals are we trying to accomplish? Best practices, and then kind of what solutions are out there to help us do this data center separation, and we go from there. So once again, I'm here. I'm joined by Jay, and I got Davis here on our from the data center team inside our Cisco side, and so we'll kind of go from there. I think we'll pick up off where we kind of talked about. If you haven't split it off before, if we go that route and we start looking at if I do need a data center, how do I design for that? Like, what do we need to start focusing on when we start thinking more of a different way towards data center?
Yeah, and and that that architecture has evolved over time. And Jay brought it up in the first call. In the old days we would do the traditional core distribution access layer, and that's as we get these much more robust switches in the data center, switches capable of layer three multicast, etc. Um, we get to the point where we don't necessarily need those separate layers, and really now we're at the point where you add switches for capacity, right? So what we're seeing in the data centers today is you do typically still have a core layer, and then more or less just a distribution layer, and that distribution layer is really just for port count, whatever that looks like, right? The modern design of the data center now is spine leaf. Spine leaf has some advantages in that everything, in a true spine leaf topology, like all of your leaves are connected to every spine connected to every leaf. That means that every leaf is 2 hops away from every other leaf. So it's very predictable, very redundant and resilient. We have VPCs or port channels everywhere. A lot of resiliency built into that data center.
Okay.
Yeah.
And I know one of the things that we've talked about often to customers is also then you like designing for a data center. We remove the need for spanning tree. Like we're trying to get rid of that. We don't want that traffic in here. We don't want conversions. And so like you brought it up with doing spine leaves, traffic flows are supposed to go. There's a kind of like a hierarchy of if you're adding capacity, if you just need ports, you just slam that back up to the spines and you just added more access ports onto those without adding another trunk down your
Right.
stack of where the fiber goes.
Right.
Um, so if we remove spanning tree, what else? How do we do for designing on the data center? Like if we're trying to get 999s, does that mean I need to look at like DR, or do I need like look at maybe an active environment type of stuff? What do we? How does that kind of look like?
Yeah, and you bring up a great point. I mean, in modern data centers, I make this analogy all the time. If you bring up an app on your phone and you go to open, say, Netflix, you never see it say, "Oh, sorry, Netflix is down for maintenance right now. Come back in an hour." Like, and if you did, you would be really
Yeah.
upset. You're like, "I spent a lot of money on this. I don't expect that. Maybe I'm going to go start watching my movies on Amazon Prime or something like that." Right? So, no, our expectation is it's up all the time. There's no amount of nines that's acceptable. It's infinite uptime. So how do we approach that, right? And kind of the current nirvana of uptime is active active. You have two data centers, or at least two data centers, and your applications run full time in both data centers with some sort of global services load balancer sitting out front of it, balancing traffic between those two data centers. And then the beauty of active active is at any moment, if you have a failure in one data center or you need to do maintenance, you can just steer all the traffic to the other data center, do the work you need to do, steer it back. Customer feels nothing, right? So that's the ideal. Now, active active isn't easy to do. There's a lot of challenges there. Data replication and applications often have to be rewritten in order to accomplish active active. So the next step back from that is DA, or disaster avoidance, right? So we're talking about where you have two data centers, but and you'll hear the terms DA and DR a lot. I hear those terms a lot as I go out and talk to people about their data centers. I really draw a significant distinction between disaster avoidance and disaster recovery, and these are important distinctions to draw, right? Most companies have a secondary data center, and they have all of their data backed up to that secondary data center, and they can run out of that secondary data center. But in a lot of the companies I go to, if I ask them how long would it take you to come up in that other data center if something happened in your primary, it's a matter of days or even a week to get transitioned to the other data center. It's not something they do quickly or easily or on a regular basis. That's disaster recovery. That's something very bad happened and I can't fix it in my primary data center, or my primary data center is gone and I'm recovering in my other data center. Disaster or DA or disaster avoidance is I have a secondary data center, I can run out of there, and I have optimized my practices so that I can do that transition very quickly. I practice it on a regular basis and I transition on a regular basis and run out of either data center at any given time. So with DA, because you're frequently leaving a data center, you can always schedule the maintenance, the needed maintenance you need to do for the data center when that data center is empty. So these are important strategies to think about as you're going forward through your multi-data center design. And some of those secondary data centers, we can include public cloud there. Maybe your secondary site is in the public cloud and your primary data center is on-prem. The concepts of active-active or DA are still entirely valid and still important to consider.
That's what I was going to bring up. Can you make your... Oh, sorry. Go ahead, Jay.
I was just going to say, you're kind of blowing my mind here because I've been DA or disaster avoidance, and you're absolutely right. Like we've seen customers all over the spectrum in terms of yeah, we have a secondary data center, but we're just replicating data there. There's no servers, there's no infrastructure, like, but the data's there, and that truly is a DR scenario. And a lot of our customers are in between that and truly active. But I love the description of disaster avoidance. That is true active standby data center networking.
Yeah, and that's where I was going to add in. So if you go down that route of doing like disaster avoidance, are you able to leverage public cloud for like that second one? So if you have it teamed up right, you can use the public cloud to, like, something bad happens on-prem. Can you run things out of your data center if we host it right? Like this whole design concept with our data centers, that would be like an end goal, right? The ability to where if something happened on-prem, your public can kick in and start taking over until you resolve those.
It's absolutely true. I mean, a lot of the dependencies there are really built around the application and what the requirements are for the application. And there's some things that just can't run on the public cloud, or they're very challenging to run in the public cloud. I have a lot of customers who still have mainframe, and it's really hard to do mainframe in the public cloud. IBM's got some stuff out there. It's expensive, it's hard to do, and it's hard to get to, but it's an option, right? There are challenges. In some cases, your applications need to be rewritten to tool for public cloud. We haven't really talked about containerization, but really that's the direction everything is going. And that's something that if you don't know about containers today, as a network engineer, you probably don't, you don't write apps for containers. You probably don't have to deal with it. But if you don't know about it, go out and do some research and look it up, because it's really important. And it's where all the kids coming out of school writing apps, they're writing them for containers. And as a network engineer,
we did a video on containers for dummies, or containers for dummies.
That's awesome. That's great. No, I'm glad to hear it. Yeah.
Go watch that one. We'll link that.
Absolutely do that. No, it is at the networking and containers, it is you really have to scratch your head on it. It's very different. So as a network engineer, even if you're not going to be writing apps for containers, you should understand how containers work and how container networking works. So.
Okay. Well, to sum up, some of the reasons, like things that we think about when you start designing a data center is, the removal of traffic that's not needed anymore. We get rid of spanning tree. We make things more centralized. We move towards a more active environment to where if something happens, we can, like the perfect, like you said, disaster avoidance of not having to replicate, like bring that site online. What is it? I mean, I have stuff there, but I can't use any of it until I either activate these, change routes, all that stuff. To where if you have it more active, you can have different maintenance windows. You can actually truly be nimble in those instances. And then lastly is the ability to throw it in cloud, to where if you already have this design idea, it's easy to be able to spin up those resources for connectivity because of the way that we're already designing our data center. So I think what we'll do now is kind of focus in on the Cisco side, kind of what we can do to help with this data center, what tools we have, the ability to start separating those. And I think we'll kind of start with, if we're just, and we 1, 2, and 3 on the automation side, we'll kind of go the same route with them with the data center. And so Cisco has NXOS, which is the basic operating system that's running on the Nexus data center switching line. Kind of what do we need to look at if you're not quite ready to go full blown into like a software defined networking with ACI, or if you're still a little scared to try data center network management, which is a little smaller version of doing like ACI. Let's say I want to separate it. I'm not ready to grab this. I could buy Nexuses, but what would that look like for my data center? How would we kind of design for NXOS?
Sure. Yeah. And absolutely, NXOS is a workhorse specifically designed for the data center. If you're comfortable with your traditional CLI, iOS, the transition to NXOS is fairly simple, right? It is a lot of the same commands work in both environments. We already talked about the architecture of kind of a core distribution architecture. The Nexus switch is a very robust switch. The nice thing about Nexus 2 is that it has open APIs, and you can start writing, Ansible, Terraform, Python scripts, whatever, to automate your Nexus devices directly. You don't just running an XOS mode. You don't have to have an SDN. You can kind of roll your own SDN for that matter. But in terms of like how the NXOS is configured, it's very much like what you would do in the campus. Obviously, we talked before about like a spine leaf topology.
Yeah, I was just about to bring that up. That means we don't carry our bad practice from the campus side of trying to put everything. It's like, you just got one Nexus chassis that I'm using, maybe, and I'll throw everything in there. It'll be fine. It's like, no, we're trying to, we don't want to do that.
Right.
We still want to follow that break of a spine leaf to where we have like our 2 cores that are handling all the routes, and then we would kind of just put in some access layers for just port availability, right? Is that the way to think about the data center?
Absolutely. Now, when we move into, the ideal modern underlay architecture for the data center is VXLAN, some sort of EVPN solution. And really, you're getting to the point of, and this is what ACI will automate, and we'll talk about that in a few minutes. But the idea of making every Nexus switch in your data center its own layer 3, it's layer 3 separated from everything else in the data center, and then you encapsulate all that layer 2 traffic. And that means that all of your pathing is based on layer 3 rules and routing rules, and leveraging things like BFD and routing dynamic routing protocols to manage even the layer 2 traffic traversing from one switch to another. And there's a lot of power and high availability that comes with that.
Are you suggesting I shouldn't be running 802.1q trunks all over the place, like even between data centers on my WAN?
I mean, you should absolutely. Okay, by the way, I'm going to put the big sarcasm flag up here. You should absolutely run 802.1q trunks across your WAN. And by the way, no, I do not mean that. No.
We've come a long way since those days, right? I mean,
yes, we truly have.
We get faster convergence. We scale much better. Redundancy is a lot easier to build in.
Right. Absolutely. Yeah.
Okay. And so let's say so just more of a hardware side, you could start that by 2 cores, and then you would just have like 2 access switches. And if your switches had a NIC in it, you could dual home on both of those, like on one switch, on another one, to kind of get that HA to, if a access switch died, it'd still be able to use it on the other side. Is that like a good way of thinking of it?
Absolutely. Now, I will say a key benefit, or an important benefit of NXOS, is the VPC, right? And that idea that you're building port channels off of 2 distinct different switches down to your end devices. And what that means for resiliency and redundancy is that I can lose a switch, and that same port channel still carries the load, right? VPCs in NXOS mode still require a peer link between NXOS devices, so you don't quite get away from that idea of linking together your peer devices, but absolutely, a core layer, and then a distribution layer, and between them. And for smaller data centers, I see customers all the time doing a completely collapsed core where it's just 2 Nexus switches in the data center. You only have a handful of servers there. it probably isn't the demand for a separate core in distribution.
Okay. Okay. Well, we've done an XOS. So then, like the next one is, and I'm not sure, maybe a lot of people don't know about Data Center Network Manager and how DCNM kind of has a play in our side. I think people either think NXOS or they think ACI. They may not be aware that there's something in the middle that's kind of like a starter to get up to there if you want. You want to just kind of explain what DCNM is, and then kind of if we wanted to go that route, what would it look like from a design side?
So DCNM, if we take the example of running purely in XOS mode, every time I go to configure a port, I log into the switch I want to configure, I move to the port, I type in the command. And I might, if I need to do that on multiple switches, I might type out all my commands in Notepad first and copy and paste them into. Many of us have done Notepad automation in the data center for years, right? Outside of the data center for that. But even Notepad automation has its vulnerabilities. And I like to say there are two kinds of network engineers. The ones who have left the crucial add command out of when they're adding a network trunk. You guys know what I'm talking about.
Oh yeah.
And the network engineers who lie about it. Right. We've all done it. It's too easy to do. So DCNM is a network manager where you can go and put configlets and config templates into one place, one central manager. It's kind of like that Notepad, but in this case, you put it in one place. DCNM will kind of do a little health checking on the scriptlet or the config you put in there, and then you tell it, I want to apply this interface config to all these interfaces and all these switches, right? And now you're done. There's none of this logging into individual switches and copying and pasting or managing that independently. And furthermore, if somebody goes in and makes a change through the CLI, DCNM is monitoring that and says, oh, no, I have this interface config that's supposed to be on that interface, but I see it's different now, and it can raise alert and even change it back for you. So DCNM is that step toward like a manager that can manage the configuration on all the network. And it also has some day two visibility, visibility around traffic flow through your data center and errors and bugs and that sort of thing. So, but the thing about DCNM, the other thing about DCNM and where it's kind of a middle ground between traditional networking and a full-blown SDN is that you can still absolutely log into your Nexus device and manage it from the CLI like you're used to. Go into config T, go into the interface, do that switch port trunk command and leave off the add if you want to. You can do all of that, or you can manage it from DCNM.
And so DCNM would be really well if you're trying to connect two data centers too, right? Because that gives you that overlay of trying to do like VX LAN extensions across. Like that is like the part that's really helpful if we're looking to solve problems. Is I need to be nimble and agile. I can't do that on the keyboard all the time. To where if I have that software-defined network that's there and I can add it in there, you're able to flex a lot easier. Is that a good way of also like a part of it?
I'm really glad you brought that up, Lance, because that's it's something that I hear a lot, right? I walk into a lot of customers who are still running. So let me step back first. Like as a network engineer, the nightmare scenario is when somebody calls us up and says, I need to have this VLAN trunked between both data centers, right? And I've got two data centers that are 200 miles apart, and you're telling me you want the same subnet in both data centers. And as a network engineer, I cringe and I grind my teeth, and I want to say, no, you can't do that. But we have technologies that allow that, and our application owners often say, no, it just has to work that way. It's what it has to do. So we've had OTV for a while now. OTV solves that, and there's obviously there's the idea of trunking across a WAN link. As I said before, don't do that. OTV is an option. It requires some pretty heavy hardware to accomplish it, ASR or 7K. But OTV is really on its way out. It has its own limitations. So as I was talking about before, VXLAN, EVPN, it gives you that ability to encapsulate the layer 2, forward it over layer 3, and decapsulate on the other side. One of the beauties there too is that you can use an Anycast gateway, so every switch becomes the gateway, and there's no more of this tromboning between data centers to get to the core that currently has the HSRP address, right? You just go to your closest switch. That's the gateway. You get out of the network. And so VXLAN and EVPN is the right direction to go for layer 2 stretch, which, like I said, is still often needed a lot. But it's also pretty complicated to build. There's a lot of very meticulous mapping that has to occur to build out a VXLAN deployment. You can certainly do it on your own, and I have customers who do. But it's one of the most sort of likely things that you would want to automate. And to your point, DCNM totally does that for you. There's a beautiful wizard. You go in there, you tell it, I want to stretch this network, give it all the details, boom, it's done. And not only does it build it out for you, but it manages it for you.
One other thing I like to point out when we're talking about overlay tech like OTD versus VXLAN 2 is that VXLAN is an open standard, right? Whereas OTD was proprietary to Cisco, which at the time we just had to have something to transport those VLANs back and forth, so it worked great. But VXLAN can do so much more as we start talking about ACI and start talking about VXLAN tunnels, not just between Nexus switches, but into clouds or into our VMware environments. And with an open standard, it just really opens up the door for all sorts of other crazy ideas.
Right. Yeah. Absolutely. Yeah.
And this is where I probably need to also mention, for those that do know DCNM but might not have used it lately, like it did get a pretty significant repolish. Like that GUI for it is very modern. It's much more simpler to see. I think from the few customers I've had that seen it before, they're like, that thing looks really old. So right. I do want to say I've seen like videos of it, and I've gone through it, that it's been very refreshed. Because I think we know that it's hard sometimes to bite off all the way on doing ACI, but you need features that you need in your data center, and DCNM is kind of that middle ground of, you still like to do the keyboard, if you need to do manual stuff, but we can find ways to help automate and do connectivity solutions with DCNM to bring those online. So we've gone over NXOS, we've done DCNM for trying to get into software-defined networking, and then the Cisco flagship is then ACI. What does it kind of look like for an ACI environment if that's what we're designing for?
Yeah, no, I'm glad you brought that up. So ACI is, like you said, it is the flagship product for data center networking. And it's really, if you said, I'm going to scrap networking as it was and start from scratch, and I'm going to give some application developers, like, go to design me a networking platform for the data center, this is more or less what they would come up with. I often refer to it as object-oriented networking. ACI has a number of objects that you create through the interface, and these objects have their own tasks. So like we talk about endpoint groups that are used for segmentation. We talk about bridge domains that handle the layer 2 broadcast or the subnets, right? We talk about L3 outs, channel the routing. These are all different objects that live in the object model of ACI. And it's effectively a little ecosystem, and you populate the ecosystem with all the objects, and you link them together so they can talk where they need to talk, and everything works beautifully. In terms of architecture, it does rely on spine leaf, and you have to have a spine leaf for ACI. So there's no just putting in a pair of switches and running ACI. You really do have to have the spine layer and the leaf layer, and you really want redundancy, so at least 2 spines and at least 2 leaves, etc. Everything is run from a set of controllers. It's a clustered set of physical hardware servers. They're called APICs, and APICs manage the Nexus switches. It runs on the same Nexus switches that you would use for NXOS or DCNM, but they're running their own special operating system. It's an ACI operating system separate from NXOS, and then all of the configuration has to be done through APIC. So now APIC, like NXOS, has open APIs. So if you want to use Ansible, Terraform, Python, I've heard people using PowerShell. You can automate it with whatever your favorite tool is. But you cannot go if you log into one of the Nexus switches, which you can still log into the switch and you can run some show commands, but if you try config T, it will not do anything. You will not be able to configure from there. You have to configure from APIC. But the beauty of that is there's a single source of truth, right? The APIC knows your environment. That's the truth of your environment. And the real beauty I see in ACI, if we do this presentation all the time where we map the different components of ACI out to a traditional chassis, right? The APIC is like the supervisor. The spines are like the fabric card that connect all the line cards together. And then the leaves are all the different individual line cards. When you go to configure a chassis, you don't log into the fabric and do commands there and log into the line cards and do commands there. You just log into the chassis and issue your commands. And that's what ACI does for your data center. You go to the APIC, you configure your data center as though it is one big L3 switch. And at the end of the day, that's kind of how it functions.
I really like that analogy again of you kind of break like that chassis is like your supervisor is the APIC, and then breaking the fabric like those line cards then are your spine. Like thinking that like it's not new to it network engineers to start thinking that way of like, oh, that actually I feel more comfortable talking because I guess I already kind of do that with just my chassis I have. I didn't think about relating that to I can then just control it in one spot because I'm already kind of it's just separation of what abilities are. Like you said, that's why it's like an object-oriented network. That's really a good way of thinking of splitting different parts and ways that they're handling stuff. I didn't ever think of it that way before. That's a really good way to try and just explain it to those that have not been exposed to ACI before. Is just like, oh, that's a good way to kind of talk about it.
Yeah. If you think
Okay.
about, if we go back to object-oriented programming, and most network engineers aren't programmers, but the whole idea there is that if I have a routine task I keep doing a lot in my program, I'm not going to keep inserting that same code for doing that task multiple times in my code. I'm not going to keep repeating that text. I'm going to create one function off here, one object that does that task for me, and I'm just going to call it every time I need to do that function. And ACI is the same way. I define a policy around what a port should look like, and instead of configuring every port individually, I call that policy and say, use that policy on this port to define all ports. Right?
Okay.
So it does simplify. It's a different model. I won't lie, there's a learning curve for ACI because it's very different from traditional networking, but it is a model. It's a more modern model, and it is probably something that maps more closely to other cloud environments. ACI is really just an on-premises cloud, much like a public cloud would be. So this maps more closely to that model.
Yeah, that's exactly what I was going to pull it up. Like this is where ACI is so powerful is because if you start talking cloud, you can spin those up in any cloud to then you actually have your network to use settings to configure up there. Like you can't throw a Catalyst switch or a Nexus in the cloud and like, yeah, I'll take care of it. I'll program it. Like that's done.
Right.
But with ACI, you have the ability to, what you're used to doing day to day on-prem, you can do in the cloud and do orchestration and set workloads and like it's just the possibilities open up so much more if you gotta if people are going there and you embrace that cloud aspect, then you got to have a way to manage it. And ACI is our tool of being able to do that.
Yeah.
What would it
Yeah.
look like if yeah, go ahead.
Well, I was just going to say, you make a good point about ACI making it possible to manage workloads in both places, but it's also from the learning curve perspective. If a network engineer is going to learn a new technology, and you're going to start putting workloads into AWS or Azure, for example, you want to learn all the different public cloud providers you're going to be using, plus whatever you're going to be using on-prem, or do you want to learn one new technology, be able to use it in multiple places? And that's where ACI really shines.
Yeah,
right. Yeah,
that's such a good point, Jay.
Absolutely, and there's another key point that about ACI, and it kind of ties into the multi-cloud story too, is that one of the things that is native to ACI is security, internal security within the environment, right? You think about your traditional NXOS or even DCNM network. If I stand up a subnet, and then maybe it's a /22 server subnet, not uncommon for me to go into a customer and they have a server VLAN in the data center, and basically all their servers live in that data center, and it's a /22 network, right? In your traditional NXOS or older environment, to put security between those different servers, to say these are my domain controllers and these are my email servers or whatever, to put security between them is very challenging once they're all in the same subnet. And to go and tell those server owners that they need to re-IP them because I'm moving them to these subnets, You guys have all been there before. You know what that's like. It doesn't happen. With ACI, I can define these endpoint groups, and you can use VLAN tag, and you can use a number of characteristics to define who lives in that endpoint group, but without changing the IP address on the server, without really changing anything about the server at all. I can say this server now lives in maybe my domain controller endpoint group, and then this other server lives in my email server endpoint group. And then I can define policy between those two endpoint groups and say they're only allowed to talk on these ports and protocols. And it's a lot easier than ACLs on a switch. We've all written ACLs on a switch, and we all know what a pain in the butt they are to troubleshoot. And ACI makes that a lot simpler with the contract model for east-west security. And then to your point about public cloud, to bring this back around to where we started, we have this model defined in ACI, this tenant structure around EPGs, bridge domains, contracts, and all of these things that are very ACI terms. But we have this multi-site orchestrator that takes these terms and it can orchestrate those same terms into the public cloud. So I can build out my tenant structure for ACI in terms that I'm familiar with ACI and MSO, and I can say, take that same tenant structure and deploy it in the public cloud. And now I have the same network space in the public cloud, the same network architecture in the public cloud, matching what I have on-prem. And there you go. There's your step toward a DA or a DR site. Right?
Yep.
And making sure that it's consistent. If I change a policy in my on-prem data center, it gets changed in the public cloud at the same time. We maintain that consistency.
Well, I think we'll kind of sum up from here. Jay or Davis, anything you guys want to add on any of this before we quickly do a wrap up on it?
I would say so. Like I said before, ACI is very different. It does have a bit of a learning curve, and it can be a little scary that it's different. But lots of YouTube videos out there. We run test drives all the time. Just go out there and get your hands on it and kick it around a little bit and see how it feels. It'll feel weird at first, but you'll get to where you like it.
Nope. All right. Well, so just to summarize, like we've talked about, if you're ready to break that off, you could do Nexuses and just start with NXOS to kind of just an easiest way to split them. If you're looking for ways to manage that, to get rid of repetitive tasks, to solve connectivity problems, multi-sites, you can start using DCNM. And then to really get the power of having a data center that's separate is using ACI to be able to add in public clouds, to be able to add in sites, to add in programming. And most importantly, like you said, David, security to ensure those groups that you want talking are only talking where they should be, and then consistency no matter where it is, because you can manage it all from your one authoritative to handle it. So with that, hopefully everybody enjoyed our data center design talk. I appreciate Davis. Thank you for joining us today. Like you said, we always usually have some type of learning. If you're interested in this, hit your teams up, hit us up. We will definitely sync with you and talk about it, and then we'll go from there. So thank you, everybody. Have a great time. We'll see you on the next one.
Thanks, guys.
Yeah.